Alright, I'm going to show you how to operate the robotic total station. Start off with make sure that all the batteries are charged. All the batteries being the data collector battery, the 2 of these robotic total station batteries, and this 1 battery for the active prism. And I'll go over a little bit more on the charging. This is the charging stand for the robotic total station battery and the active prism battery. They just slot right in there. There's a minor difference between the charging adapters. So if you'll notice, this 3-prong plug here, as well as the 3-prong plug on the adapter, as well as this step in the barrel plug, allows it to fit inside of this port on the data collector. Whereas on this charging adapter, it does not have a step on the barrel plug, and it is only a 2-prong plug. And you'll see it just fits right in there, no step needed. This adapter cannot fit in there. It's a different size. However, the correct plug for the data collector can fit inside of the charging block or charging stand for these batteries. However, no damage will be done because both of these adapters output the same voltage, 19 volts. So that's all I need to cover on the charging of the devices. We'll move on with initial setup. So in this case, let's say we haven't used the total station in a while. It's recommended once a month that you give it a calibration, and we're going to start with that. We'll begin by turning on the data collector with this power button, and we'll extend the Bluetooth antenna up. And while that turns on, we'll start setting up. The first thing you want to do after you're done transporting your equipment and before you begin is doing a field calibration of the prism pole. So the prism pole stored in this bag, there's 2 prism poles. It's always tricky to get this out of the bag because it is exactly the same size as the bag when we stuff it in there. So the field calibration of the prism pole is basically to ensure that this bubble is still mounted perpendicular to the prism pole itself. Because if this bubble were to loosen during transport, you won't be able to level it out accurately. A little bit on the operation of this prism pole. The prism mounts onto this screw up here and allows you to set it at specific increments. So let's say 5 feet. This screw mount will be 5 feet above the point on the ground, and this is where your measurement will be. So the goal is to use these buttons on the bipod legs Depressing it allows you to extend and retract each of the legs, and if you pulse them and move and adjust the prism pole until it's perfectly level, then that will ensure that the prism pole is plumb and that the prism up here is exactly above the point on the ground that you're trying to measure. This mount connects to the back of the data collector and allows you to carry all of them as one unit. We'll go ahead and remove that for our field calibration. And to begin the field calibration, you want to take the prism pole to a vertical surface. And you're going to want to adjust, loosen this, and bring them up nearly to the top of the prism pole. And you don't want to tighten this down too much. You want to be able to move it and rotate it freely. So, to do the field calibration, you want to rest this back screw against a wall and just leave the bipod legs out to stabilize it, and then just lift and position the prism pole so that the bubble is perfectly in the center of the circle. And once you get it close as you possibly can, it could be kind of tricky because we're on a rough concrete surface. The point is getting caught in the grooves of the surface. But once you get it close, you're going to want to make sure the screw is loose enough that you could spin it freely. And you're going to spin it around in a few different locations. I picked 3 locations to make sure that the bubble stays centered. Let me just get that centered. The point on the floor might walk around a little bit on the surface. That's perfectly centered. Let's see if it stays centered as we move it around. Okay, that's pretty good. I can tell that it's moving on the ground a little bit, but I think this is within calibration. As long as it stays within the circle as you rotate it, you're within tolerance to use the machine. Closer to the center of the circle, the better, but this is just a field calibration. It's not going to be perfect. But if you were to find that this is way out of calibration, and as you spin it around, and you know that the bottom of the point isn't walking around on the ground, you'll want to adjust the screws up on the bottom of the bubble level. And you can see them here, 3 screws. And they adjust the levelness of the bubble and how perpendicular it is mounted to the pole. And I would recommend you do that on a better surface than concrete, where the bottom of the pole isn't going to walk around in the grooves. Possibly on like a carpeted surface, where the point could just stay in one point. And then you'll adjust the screws the same way we spin it around to determine the calibration. So you'll spin it around, find a location, make sure it's level, spin it to the next spot, and then you might adjust one screw to bring the bubble level closer to center. And then rotate it again, adjust another screw to bring it closer to center. and then keep going, making small increments of the adjustment screws on the bottom until it's perfectly level. But that's within calibration here, and this is not the ideal way to do it because there is a specific tool that you mount to the wall. So this would be the point on the bottom that the bottom of the prism pole sits in, and then this would be mounted directly above it, as far away, or as far up onto the pole as you can get. So then you would adjust these screws to hold the prism pole perfectly centered between them, centered on this point, and then that would be adjusted for this diameter of prism pole, this prism pole in particular. So then that's how you would have a consistent jig to calibrate this bubble. However, it's been like almost 3 years, and we don't have anywhere to mount this on a wall. So I always do field calibrations, and this is something that you should do before you use the total station every single time, just to ensure that the screws on the bottom don't shake or wiggle loose during transport. Alright, I'm going to put this data collector mount back on. Just going to put this to the side for a moment. We'll discuss this other prism pole that's in here. There's a short prism pole here. And there's also another entirely different prism pole. So I believe you can see TopCon on here. This prism pole came with our previous TopCon unit. It is pretty much the same as this. However, they might be different diameters, so you wouldn't want to use this calibration if it's mounted on both of them, unless you can determine that they're the same diameter. This is just an extra spare that we have from one of our previous units. You'd probably put this in the GTP, that meaning get the point XY positioner metal base that's in the shared storage. But for now, this is just an extra. The short prism pole, you would still need to use the same bipod because we only have this, or you could do this by hand. Instead of using the bipod, you could walk around with this, try and level it out by eye, hold it level, and then shoot the point if that's possible. Or one good reason you'd want to do this is, let's say you need to collect sleeves, collect the center point of sleeves, and they're all sticking up at different levels on the ground. It would be very difficult to get this, let's say this is a sleeve, to get this prism pole all the way up here, you see, and you could always adjust this pole, the bipod legs to be at the bottom, and then the prism pole is all the way up there, and then that's where it's very awkward. This is exaggerated, but in situations like that, it might make more sense to use the shorter bipod that we carry around in the bag. So I'll put that to the side, mount this guy in here. And now that is a lot more reasonable to do. So if you need to collect points on like elevated surfaces, let's say I need to collect a point there, it's easy to level it out like that, and the prism isn't super high up off the ground. So that's why you would use a shorter one. And it would be tricky to make sure this is leveled. I've never used this in that sense. because I didn't realize we had it when I could have used it. So I'm not sure how to calibrate this, ensure that the bubble level is calibrated. I had a tool like this mounted for each of these. Or just have one and adjust the nuts and the bolts for every single time that you check the calibration on them. Anyway, we'll continue on. So we completed a field calibration of this prism pole, and we've ensured that it is in a usable condition. So next, we'll start by setting up the tripod. So this yellow tripod is the main tripod for this total station. In the case of just a monthly calibration, where all we need to do is place this in a spot that you can walk and have line of sight about 65 feet away. So this is plenty of room. I'm just going to place it right here. I'm going to unbuckle this. Going to loosen all these latches and make sure the knobs are also loose. Step on one leg. Bring it up about chin level. It also it's not super necessary what level height you put it at. And then once you have it at a height that you're happy with, lock one down and then bring the others to match. And then spread the legs out. And my general advice for the height in which you want to set up the total station is so that the top of this plate here is at about collarbone height. And if you're working with multiple people, make sure the height is compatible for the shortest person that is using it. All right. So continuing on, it doesn't exactly matter what height you put it at for the calibration, but we're going to roll right into a data collection scenario right after this. So I'd advise keep the height at a comfortable collarbone height. I'm going to remove this so it's not flapping around in the breeze. That could affect your measurements. You're going to notice here this webbing here. It can slip out completely, so we just want to keep enough extra here so that we don't lose it. This webbing keeps these legs from sliding and pancaking out if it's on like a slippery surface that the spikes of the feet can't be buried into. So if you were on a soft surface like dirt, sand, gravel, whatever, you would want to bury the spikes as far as they can go so that they don't sink and that it's just stable at a constant height. However, these points are pretty sharp, certainly sharp enough to cause some damage to surfaces that you might not want to damage, like if you're working on tile or the PTO surface or TPO surface of a roof. This could puncture the tile or the plastic membrane of a roof. In that case, that you would want to find some scrap material or something to put underneath the points of the legs just to protect the surface. So now we're just going to adjust the legs so that the top of this is roughly leveled out by eye. The closer to level you can get now, the better, the easier your job will be later. Alright, so I'm happy with that height and that levelness for now. Before you put the total station on, you want to make sure that these are snug. This is just an extra precaution so that these legs one of the legs don't slip down. And we're going to get the total station out. All right, so I'm going to pull this out. We're going to rest it on the plate on the top here, center it up, and make sure that these adjustment knobs, the 3 of them, are directly over top of the legs. And we're going to continue to hold the total station, and we're going to screw it in and secure it. That's secure. And just to show you a little leveling tip, you can twist this latch, release the total station from the tri-brack, put it back in the safety of its case, and you can see this bubble level on the top here. And if you're on a really uneven surface, this bubble would help you out a lot to get this plate leveled out as best as you can by eye, only using the legs itself. But in this case, we should be within a close enough range where we could adjust the levelness with just these tri-brack knobs. And you want to adjust one at a time. Until you bring it in to be level. And once you get it close to level, it'll make your job even easier once we get to the fine adjustment leveling within the total station itself. So we're going to put it back on here, align these power connectors with the cutout on the side of the tri-brack, and make sure that's locked down. Don't put too much pressure on the total station. Make sure it's secure. It's not going to fall out. And we will turn it on. I already have a battery in here, but battery tray is on this side. And you can see battery charge indicator. Press that button, it'll give you a percentage. And you want to insert the battery into the battery tray. And then close the door. And on the opposite side, has the button here. Turn on, light turns green. And starts up. And you want to look at the screen. This is one option to level the machine. While it's in the countdown mode, press the right key, or the enter key. In a second, it will come up with the leveling bubble, the digital level bubble. Okay, so there's 4 different levels of sensitivities. We're at 1 to 250. And you can see that the smallest circle is within the slightly larger circle. The smaller circle being our bubble. We'll go down to a more sensitive mode, and it's 1 to 100, and it's still within the circle. And now in 1 to 10, you'll see it's a little bit out of level. And this is a pretty sensitive mode. So we're going to make very small adjustments to the adjustment knobs, just one knob at a time, until it's close as possible. And then the most sensitive mode, 1 to 1, this is very sensitive, and as long as you're close, I barely touched the knob and it moved. As long as you're within, like, touching the circle, I would leave it at that, and we'll further level it. We'll fine tune that once we're on the data collector. So now you can press the exit button on the left side, let it go through its countdown, and it'll start right up. We'll take the prism out for now, and we won't need anything in the case. Of course, it's always a good idea to make sure that the glass and the sights are clean on the tool station. There's this lens that you look through. There's a rough sight on the bottom and on the top. Make sure those are clean. And then the main aperture on the front, make sure that there's no smudges or dust or any spots on it. And this is cleaned beforehand. Make sure you use a microfiber towel with a little bit of lens cleaning solution on it. And so this machine is water resistant, rated for use in rainy conditions, but still don't spray directly onto the lens. Spray it onto the microfiber cloth, and then wipe down the lens from there. Okay, so we're going to continue on our tablets. All started up now. Make sure that it's in airplane mode, Wi-Fi, Bluetooth off, so it doesn't interfere with the actual Bluetooth module that connects to the toll station. And now we're just going to open up Trimble Field Link. And while that turns on and opens up, we're going to just place this battery in the active prism. Don't turn it on for the calibration step because it requires that the prism be turned off during calibration, but afterwards we will be turning it on. So I'm going to screw it on there. I'm going to make sure that this prism pole is pinned at 5 feet, and then we're going to lock it down there. We are going to take our data collector and lock it into the mount there. Press the button on the top, let it slide in, make sure that it is secure. It is pretty secure, but I would not put a ton of pressure. Like if you're carrying it on your shoulder, don't hang the data collector off your shoulder like it's a hook, because it can pop off. Okay. So now, what we're going to do is connect the data collector to the toll station. So we'll go to, on the top here, the menu bar, or the ribbon, we'll go to Device. Make sure that the toll station icon is checked and that the channels and network shown here matches what you see on the front there. That is how it came from the previous recalibration when we send it into the equipment reseller. These channel and network you might have to adjust to avoid interference if there are multiple machines on the same job site. If there's 2 machines and they're both on the same channel and network, they're going to interfere with each other. But for the most part, I've never had that scenario occur. We'll connect give it a second to do its thing. Okay, so you'll see next service date. This service is when you send it into building point for the annual recertification and cleaning. It's overdue, and we'll X that out. And you can see sighting, trunnion, and this little bubble, those are the bubble levels, but just on the data collector. So you want it, the minutes, seconds, you want the seconds on the right hand side here to be as close to 0 as you can get it. And the machine is so sensitive that we're on top of a parking deck. If cars moving on the floors below will affect the level, me walking around it could affect the level. So you can imagine if you're set up on like a working deck, a wooden working deck that's really bouncy, that could have these numbers fluctuate quite a bit. But get as close to 0 as you can, under 10 seconds ideally, but as close to 0 as you can. I'm really happy with that. There's no point in adjusting it, but if you do adjust it, you want to rotate the machine so that it is directly over top one of the adjustment knobs, and that will give you the sighting. Sighting being the machine leaning towards or away from you, and then trunnion being the machine leaning right or left of you, or when it's facing one of the adjustment knobs. Doesn't matter which adjustment knob. So that's just an easy way to think of it. So I'm happy with that. We're all connected. We want to make sure that the toll station starts tracking the prism. You can see that hexagon that's spinning. When it's spinning, it means that the toll station is not locked onto the prism. And it is not locked onto the prism because it is looking for the prism in active prism mode. However, it's turned off, so it is in passive mode, and it will not detect it in this mode. But for the purposes of the monthly recalibration or monthly calibration check, set it to passive mode. And rod height is at 5 feet, that's fine. And we're going to exit out of that menu. And now we can press this hexagon with the question mark in it in the middle, and the toll station will proceed to scan the area and look for the prism. It might not find it. We might be a little bit too close for it. Oh, there it goes. No, it didn't. There it goes. So now you can see there's no question mark, and this one isn't spinning. That means it's locked on. And one thing to note, whenever you are setting up the machine and you're planning on walking away, make sure it won't get damaged or hit by a vehicle or something. I'm kind of in the middle of this parking structure, so there shouldn't be too many vehicles moving around here, but just make sure nobody's gonna knock it over, or no vehicles are gonna hit it. Ideally, I would have cones to section it off, but in this case, we're just on a quiet area. Keep it safe, because it will get knocked over. It's been knocked over once before. Thankfully, no major damage was done. We'll start. Calibrate instrument. Aim prism at least 65 feet away. You can see the onboard camera picking us up with some major lag, but we'll start by walking away 65 feet. It doesn't matter what direction you go, as long as you can maintain at least 65 feet of distance. Gonna go all the way to the end here. And we're going to level out the prism pole. Once we're happy with that, hit measure, and the total station will lock onto it. It will rotate around in different axes, and then it will try to reposition itself onto this locked on position, and any deviation from where it thinks it's looking and where it should be looking, it'll spit out a report and tell you whether it is within calibration or not. Calibration results stored, succeeded, instrument calibration successful. You could save it if you want. I've done this a couple times in recent past, so we're not going to. And we're good to go. I'll put the date, the last time you did it. I'd recommend, if you haven't used the machine in a few months, make sure to do this before you begin using it again. If not, if you can get into the habit of just taking the equipment out every month, doing a little refresher course, and calibrating the instrument, make sure that everything is in good operating, working conditions. So now we're ready to continue on. You can see we're at 83% battery life on the total station. The fully charged battery could comfortably get me 5 hours of use, possibly up to 6 or even a little more. After 5 hours, I'd be looking for a good opportunity to switch batteries. We'll begin. We'll go to more, jobs, manage. I have a scenario here. I'm just going to, can't delete it because it's currently the one open. It always opens up the previously used job. So what we're going to do is create a new one. Scenario 2, create. I just want to go back into more, jobs, manage. Select that, but delete it. Yeah. Example, delete that as well. Yeah. We're going to keep this guy here. And since that car just passed, I want to go to device settings. See if it's still within level. Yeah, that's good. Okay, so now we need to, in this scenario, we are going to be collecting data from scratch. So we're not importing a CAD file or anything. We're just going to bring the machine out on the field, set it up in a good location, and start collecting data. So to begin collecting data, we set up in device, set up. And here is where you set the project north, or what will be on the top of the screen, how the whole plan that you create aligns to the screen. Ideally, you could have it all orthogonal and have north be north. It doesn't always work out that way, but I'll show you how it works. So you're going to select north and a base. So basically you're going to take this prism pole, you're going to walk as far in the north direction in relation to the total station as you can go, and shoot a point, and then you're going to walk directly south of the total station. Either north or base can be as far as you can go. Whichever is further is better, and I'll get into that as we're walking here. So it doesn't matter what order you shoot the points in. We're going to start with north. I know that north is in this direction. As I'm walking, I'm holding the bipod legs and I'm keeping the prism above my head, so I'm not blocking the prism. It requires line of sight to the prism in order to see it. if I were to keep it in front of my head, the total station would not be able to see it, and it would lose sight. So get as directly north of the total station as you can, level out the bubble, and the point you place it on does not have to be repeatable. Ideally it would be a repeatable point, like have a reference mark on the field that you can repeat this measurement, but it's not necessary for this step. This step you're currently only defining project north. So we are going to shoot. We're still in passive mode. It will still work, it just will take a little bit longer. We're going to pick it up and walk directly south of the total station. And as the closer you get to the total station, the faster it needs to move to keep up with you. So give it a second, slow down when you're close to it so it can rotate and maintain its lock. So, like I was saying earlier, one of these points has to be as far away as you can get. That makes sense, because the furthest point that you're collecting here is your working distance around the total station. So like a radius around the total station, a circle around the total station is how far you could work within this tolerance. This being like perfect tolerance, there shouldn't be any deviation unless you set up the machine against these 2 points, and then you stray out of that radius, and then you're going to start introducing errors from like stack tolerance, since you're outside of the you're outside of the setup range. So we're as far back as we can, directly south. I'm going to shoot another point. This is going to determine our base, because we're south. So we're going to pick north. It says north now. Pick base, and now if these points were not in a straight line, if one was at a weird angle, it would rotate the whole machine to one way or another. It doesn't really make sense because this line doesn't become north. It's like it needs, I don't know, I can't explain it, but this is how you get your plan to be orthogonal, as orthogonal as you can get it. That's not always possible. Let's say your site is longer east to west, or east to west, like this job site is, than it is north to south. We will not be able to capture points all the way at that end because it will be out of our working distance, because that is way longer than this distance here. So in that case, if I needed to capture points on this entire job site, I would need to sacrifice this nice plan north view and collect a point all the way down there and all the way the opposite side to cover my working distance. But the plan will be like rotated 90 degrees or something, and it'll look a little strange, but at the end of the day, all the points are still going to be located correctly. It's just awkward to read when the plan is rotated strange ways. Okay, I'm going to live with that. We're not going to be working all the way that far or not, or right now. So we're gonna set. I'm happy with that. So before we start collecting points, I am going to turn this prism onto active mode. I'm just gonna turn this dial on here. You can see these LEDs turn on. One on the prism to match one on the RMT ID. And then we're gonna change mode to active to indicate that it is on. So active meaning that you have a fully charged battery. If you have battery life, always use active. But of course it does work in passive mode if you run out of batteries. And it doesn't matter what RMT ID you use as long as they both match here. So we'll continue on. I'm going to go to measure settings. You see this little flag and this little shoot icon or this little star. I'm gonna go there, make sure it's in high precision because we're gonna begin with collecting reference points or control points. But you can always choose. High precision takes a little longer to collect the measurement. Fast precision is a little bit quicker. It might sacrifice some of that precise precision. Alright, so go back to the measure menu. We are going to actually never forget this device. Once you set up, then you set your reference elevation. It's very important that you have a known point to reference your elevation. Even if you don't have like a survey benchmark indicating the NGVD elevation or whatever, set your own point that you know is repeatable so that all of your points, if you were to move the machine around, you could always reference that one point, and then all of your collection all the points that you collect will be in reference to the same elevation. They'll be consistent. So in this case, I don't really know where I would want to reference. Maybe I don't know, let's say this layout line here. This is a known point. I can reference that in the future. So I'm gonna go down here, make sure this point is directly on that intersection, that chalk line. I'm going to level out this. I'm gonna make this my 0, 0 point, but you could adjust the level to any number you need. We're on the 10th floor here, or the level 8 parking. I think it's actually the 9th, 10th floor maybe. We can make this like 90 or 100 feet or whatever, but I don't know the exact level of this slab, elevation of this slab. So make this my 0. We're gonna measure. It's not locked on, actually. You can see that spinning. So we're gonna go into the camera. You could also go into the middle circle. The camera gives you a little bit of a visual, and we just tap where the prism is on the screen, and it will rotate and lock on. So you can see I locked on there, and we're going to exit out of the camera. Okay, make sure we're still plumbed up, we're on the point, measure, and that will become our 0, 0 point that we could reference in the future. So the machine referenced that as our 0, 0. However, now we're gonna collect that point before we move. So I'm gonna go to measure. We're going to collect. I'm going to rename the point. I'm gonna say ref elevation, and we're gonna put it under a layer named control. Tap control, and I'm going to collect that point because we referenced it, but we didn't actually collect it as a point. And it's always helpful to have, collect all the points, because that way you could even lay this out in the future. Okay, so it's always helpful to collect the reference elevation. We're going to continue on by collecting some more control points. For example, let's say there isn't much control for me to, well, how do I put this? Let's say we want to collect like the bolt pattern on this bollard, maybe the corners of the housekeeping pad, the striping, corners of the striping. Those are the things that we want to collect. We need a more permanent point. We need more permanent points that we can reference the machine to in the future. If we need to, let's say this is getting demolished and we need to lay it out again in the future, we need reference points that will not change, even though this is all gone. We can reference the machine to those points and be able to lay out these points again. So pick your control points wisely. It's always more helpful to have more than you think is necessary, and have them as far away as you can within your working tolerance. So that way you can position this in the future. In the future, you can position the robotic control station anywhere on site, and you have good control points that you can see. So there isn't a lot of great points for me to pick control here. So I'm going to just collect some of these, I don't know. Doesn't make sense to do this. That point centers itself. Sure. I'm gonna collect the spikes holding the parking curbs. And it lost us. So we're gonna go into the camera. You could also go into the middle one, and you can see in real time, toll station rotates. Ooh. Should see us. Maybe it just missed us. Oh, there it is. Tap on the screen where the prism is, and it will lock on. There's that little red plus sign. That means it's locked on. Camera didn't update. There it is. Okay, so I guess this will continue to be control, but I'm going to change the name to control. I would also recommend you keep these names as short as possible, because you can see it spells it out. So a long name will clutter up the screen very quickly. So I'm going to collect that point. Another thing I would recommend is you document the points that you're collecting. So that's control. I would take a picture on the site, give it some context so you know what point this is, what parking curb this is. Take a picture maybe in a separate album in Procore Photos, so you could mark it up with annotations, say that this point is control 1, and then when we go somewhere else to basically an identical one, and we say this is a control 2, or you could use like OneNote, any app that makes it easy for you to annotate photos, because if you take a bunch of identical photos, they might look the same. It's going to be difficult to tell, is this control 1 or 2, and so on. So take photos, annotate them so you or anybody else can figure it out in the future. I'm not going to continue collecting those specific points. Let's continue collecting some other things. Maybe these embeds, corners of these embeds. Total station lost us again, probably because I was not raising the prism above my head, so it lost me, or it lost us behind that column. So we're not going to do the camera, it's a little bit laggy. I'm going to maybe I will go to the camera now that I got it close. There we are. Okay, so we're still pretending that we're collecting control. These aren't ideal control points, but we'll make it our control points in this case. You could give it a description. Let's call it embed. Make sure that we're leveled. Shoot. You know, make sure you document which corner you're collecting here. Take a photo, annotate it, move on to the next. Maybe this corner is a little better for control purposes. Shoot. You may or may not be able to see that once it's done measuring here. You can see on the screen it overlays the where the points are on the photo. So it tries to help you, but this only works when you're set up already. Alright, so here you can see some actual control lines, or maybe these aren't actual control lines, but just layout lines in red chalk. It's possible that this is a control line intersection. It looks like it goes kind of down the middle all the way down, and then kind of down that way. This would definitely be a decent spot to pick up, because I could see the intersection here still, even though it's been like a couple years since this has been laid out. Red chalk lines are a lot more permanent than blue ones. It's a handy tip if you don't want your chalk lines to be permanent. So we're not collecting a corner of an embed, so I'm going to delete that. We could say control line or something. Let's say control line intersection. And I'm going to shoot. Measuring. High precision mode is a little bit slower. And I'm just going to collect like one more point over here, I think. Maybe on that arrow. That's the only good point around here that I can collect. And then we're going to move on to the laser mode. So right on that corner. Level it out. going to change that description because it's not a control line intersection. I'm going to say arrow. I'm going to shoot. And there it is. This control checkbox just identifies these with the black triangle in the center of the circle. Alright, so we're going to walk back to the tool station. We're going to capture a few control points using laser mode. So we're going to look through the site and show you how that goes. It's still tracking us. Oh, it lost us. You can see when it's in active Prism mode, it tries to track these LEDs and tries to track the trajectory or the path that you're walking. So when it lost us, it thought we continued walking this way. So it continued on that way, searching for us. So technically, you're supposed to be able to keep walking behind a column, and it should find you on the other side. It's hit or miss. It works fine enough, I guess. Okay, so we're going to set up the Bipod Prism pole next to it. And we are going to switch it to laser mode. So the spinning prism, tap that, switching to laser mode. If you can see here, as it's shooting a laser now. Just be careful not to aim that into people's eyes. This is just a laser pointer, so you can see it, but it can be pretty annoying and a little bit dangerous for this to be in people's eyes. It's certainly bright enough to be seen a couple hundred feet away. And in order for me to show you laser mode, you need to be able to look through the scope. And the best way I could think of showing you that would be to get the GoPro out. So I'm going to start off by choosing a point that I want to reference by eye. Let's say all the way down there on the level 8 decal, we're going to go with the corner of that L or something. So using these rough sights, you can see that little circle in the middle there, or on the top. They're both the same. There it is. Imagine closing or keeping both eyes open, but lining up one eye with that circle, the rough sight. You could kind of vaguely see what the toll station is looking at. And you use these rough sights because once you look through the scope, it is so zoomed in and it can be very disorientating. So you don't know what exactly you're looking at. Because you could think you're looking at one column, but you're actually looking at another, and you don't have any idea which one is which, unless you use the rough sight and you could tell roughly what you're looking at. If you can see that right there. Okay, so toll station is set up a little bit high for me. I didn't quite get the collarbone a little bit higher, but if I stand up straight, I can look through here. So to control laser mode, there's 3 knobs on the side here. This adjusts the focus, the plane of focus, because it has a very narrow field of view, or it is a narrow field of view, but a very shallow depth of field. This rotates the whole assembly up or down, pans up or down, and then this is pan left and right. So you can move it by hand, nothing bad will happen to it, but this gives you a very, very fine adjustment, and I'll show you how that's useful. So I'm just going to get it close. I'm going to use the rough sights and the faster you move the knob, the more responsive it'll move. So I'm going to use the rough sight, get it roughly in the correct location. Then I'm going to look through the scope. You can kind of see it. You can see the crosshair. I'm going to go through with my eyes and make sure that I am in focus so that you have something to look at. And I'm just going to get it close to that L, that corner of the L. Alright, so let me see if I can hold this steady. So you can see that crosshair, that's what you're moving to align with whatever you want to be your reference point, your control point. So you adjust the focus with the top knob, you go up and down with this, left and right with the bottom. And you could use the rough scope, the rough sights to get an idea of what you're looking at. And then there's one last adjustment. This gray knob on the sight adjusts the focus of the crosshair itself. So when you're looking through here, the crosshair can become blurry or a little bit sharper. I guess it's kind of adjusting for your specific eyeball. Oh, I can't really show you that, but I'll adjust the focus. You can see it go really out of focus. I'll try to get the focus close based on the GoPro screen. But you could imagine how zoomed in you are to those pipes. GoPro is pretty zoomed out, but look how far away you are from the pipes. And you're way zoomed in there. So that's why these rough sights are helpful. I'm gonna get it lined up again with the L because I didn't get the measurement. Look through here, get it focused. So now we're gonna do this for real. Alright, so I got it adjusted for the L. You can see it right there. Now I'm happy with that. It's still going to be control. Change that from arrow to L. Shoot that point. And now we have control number 7 on the L of the decal. So, very helpful tool. Definitely make use of that. Capture a bunch of control points on vertical surfaces or even ceiling. And you could also use that to capture any points. It doesn't just have to be control points. It could be like verifying the corners of blockouts on a shear wall or something. You could potentially use it to verify penetrations on the ceiling. Just anything, any surface. There are limitations for laser mode. Limitations being that it's a laser and it can be the accuracy of the laser can be disrupted by certain surfaces. So if it's a super black surface or a reflective surface like a metal foil, aluminum foil, stainless steel, glass, puddles, water, super saturated in water, a bright surface in direct sunlight, or if it's like really far away, maybe beyond 250 feet away, laser mode on all those surfaces or in those conditions rain also. Laser mode doesn't really work, or it might not work. It may or may not. The measurement simply might fail. There's always the chance of you getting an incorrect measurement. Those are the drawbacks of laser mode. However, it is still a very useful tool that I use all the time. Maybe another drawback is the further you go out with the laser, the larger it becomes. The beam of the laser spreads out, so it's not as sharp here, or it's a lot sharper up close than it is all the way down there on the L of the decal. Another thing is it's a laser, so once you're not perpendicular to the laser point, it spreads out. I don't know if you can see that, but it spreads out along the surface as opposed to being a solid point. So that's one those are the main drawbacks. Also, it could get in people's eyes, but it's not super dangerous. It's just really annoying. It has a lot of drawbacks, but it's also a very useful tool that has its purpose. The benefits of the Prism mode is it can go a lot farther in distance. I don't know if 250 feet is exactly right. Depends on the conditions. But after Prism mode, you'll have to check the written document for the exact numbers. But it could go really far, hundreds of feet, thousands, even in passive mode. It could also, since the point you're measuring, you're seeing this, you're sighting to this, but the point is actually being collected on the ground. So you can dip that into a puddle, and you'll still get accurate data. You can go behind a wall or something and collect points. As long as you're above the obstruction, you can still collect points on the ground. So those are the main benefits. Also accuracy. Biggest drawback to this is that you can't do vertical surfaces. I don't know how you would do, maybe it's possible, but like ceilings and stuff just doesn't make sense. Stuff like that. Also the point, if you're on like dirt and stuff, it sinks down into the soft sand, so that could be kind of annoying. If you need to collect data of sleeves when they're just holes in the ground, you put that, how do you put that in the hole? It doesn't really work out that well. You just need to collect the point next to it or something. Stuff like that. So you need a relatively solid surface, horizontal, and this could collect data as long as you don't have any obstructions. And I guess obstructions, this machine requires line of sight, so anytime you have an obstruction, you're always going to have an issue there. I collected that one point. I'll collect a couple more, maybe on that door, electrical room door. Actually, even better, we'll go with that sign next to the door. So the laser is also very helpful. Some cases you'll position the laser and you can create your own control point. Let's say you have a flat wall with no points of reference. Actually, there's a target here. Put the laser on here, right? Or mark your little thing. Make a mark on the wall, or like you can see here, I forgot about this. I was looking for this for a while. Target like that, stick it on the wall, and then look through the scope here and adjust yourself so that you can see adjust. So you can see, so you're lined up on that. So since this is close enough, instead of getting the GoPro out and trying to look through the scope, basically my crosshair is lined up right on the center of that target. This is a target that Stanley Lawrence from Datum Tech Solutions put on here for the demo he gave us of the Leica RTS773 scanner. So you could make your own control points. You don't have to use existing points of reference. And I'm going to shoot that point. Let me just make sure that I'm all lined up. Looks good. We're going to change the name or the description to target. And I wonder if I can I'll shoot that over here. I wonder if I could show you through this camera. I'll give it a shot. Let me just get up the viewfinder here. Okay, let's see here. You can see it, just barely. This is awkward. I'm holding my phone and the camera in my hand. There it is. So you can barely see it, but maybe it'll look good. Put the camera back on. Make sure I am centered right. That should be good. Okay, so I shot that point. Let's say that's all I need to do for control. I'm gonna uncheck control. I'm gonna go in here, change it out of the control layer. I'm not gonna get super into different layers. I'm just gonna say I'm collecting data. Name would be data. And then exit out of there. Exit out of laser mode. We're going to go back into Prism mode and just collect a few points. These are very similar to control points, basically the same thing, but they just don't have that differentiation of the black triangle. So we're locked on here. I'm going to collect these bolt patterns here. So let's say we want to make sure that the bolts are coming out of the embed where we need it to be, where we need the bollard to be. Good, we're gonna shoot that. Now would be a good time to go to fast precision mode, so it's a little faster. It doesn't need to be super duper accurate. So we're gonna go to measure, settings, capture, fast precision, exit out, go back to measure, collect data. Maybe I would have named that better as bolt or something. So here you can see the benefit of the Prism pole setup is this bolt is out of line of sight of the toll station. But since the Prism is above the bollard here, we could collect that data. Gonna shoot, and even though these are super close together on the map, you can zoom in there, make sure that you're collecting what you need. Line it up, center it, level it out, collect a point. Doesn't matter what direction you're in, as long as the toll station has line of sight to the Prism. So that's basically the the whole workflow of collecting points. Just go around, collect as many points as you possibly can. Yeah, it's as simple as that. I'm not going to be collecting any more points in this case because that just rinse and repeat. You just go around shooting points, changing the name, making them organized so you know if you need to come back in the future and lay these out, you know what you're laying out, what they're called, what they're named, maybe what they look like. Once you start collecting data like this, I don't really see any point in taking pictures and documenting every single thing because that'll just slow you down at that point. But for control, setting up control and knowing where your control points are very, very important and helpful, because maybe a few months in the future you might not even know where that target is. If it's that small, far away, maybe it gets destroyed. So that's why it's always helpful to have more control points. But so we're done collecting. Let's say, what do I want to show you now? Let's think here. Let's think. I think there's one more thing I want to. Let me collect one more point here. I think this might be a good spot. Maybe. Let me think here. Next scenario is we're going to move the total station to a known point. And that'll kind of cover our basis for using the total station. Known point. So I just want to identify a good sharp point that we can set up the total station directly above and still have good control lines. And it helps if you have like a, what do you call it? If it's like an X or a plus sign shape that you could line up to easily, and you'll see later what that looks like. I think this might be good. It's a nice squared off shape. If I could place the point down there. And I'll collect this as a control point. So let's say you're going in between, you're going back and forth from one name and layer to another. So 3 lines, you could pick all the layers that you've created. And then name, you can't pick it, but if you spell it out the same way, control, I think that's all I did, right? Yeah, control. It'll continue that. You see it added the 9 there. Okay. Pick control, we're locked on. I think we're in fast precision mode. In this case, it's fine. We're definitely close enough. We're within tolerance. I don't have any concerns about the accuracy of that. Okay, so let's say we're done. We have our control points. We collected all the data that we needed to verify, or that we might need to lay out again in the future, or we're done for the day. All you need to do is you can exit. Yeah, that's pretty much it. The data is saved. There's no save button or anything. So you're in a good spot to close up shop and call it a day. Okay, so we're going to do that. Going to exit. And let's say you got to this point and it crashed or something. We didn't move the total station yet. It's still in the correct spot. So this gives you the option to just continue working from your previous setup location. So if the software crashes and you don't lose everything, you can continue on, assuming that you trust that the total station has not moved. So if I go to device, we need to connect again. So connecting to RTS. Hour and 30 minutes. Hopefully I could wrap this up under 2 hours. Go home. Okay, so we're still within a decent level. You can see it's in minus. It moved a little bit, but that's still under 10, either or. And it will tell you if the machine goes out of level. It'll give you a little warning. And once you get that, you're not in a good spot to continue working. You need to reset up completely from scratch. Or, well, I think it might give you the option to level it out again, but you just need to verify that your measurements are still within tolerance of each other. All right, so we've connected. Now we need to set up. Use last instrument setup location. In this case, we are going to do yes, because we have not moved the total station, and it just wants you to check its setup. Oh, did that not work? Okay, hold on. Let me see something here. So I controlled 9. We haven't moved from 9. We're still plumbed. If I shoot that, does that tell me anything? Let me go to create point manager. Create point manager is where you like manage all the data of the points. So if I select control point 9, yeah, there's only one point there. You can see the elevations and stuff here. That didn't work. Set up. Or did it? I think it worked, actually. When you see that little yellow icon indicator, that's you. That's the prism. If I block it, it loses it. It should pop up. Yeah. Okay, never mind. It did work. I was a little confused with the new setup button. But that's if you want to get a new setup, which we do. But when you're in this scenario where you choose that option to continue from previous setup location, I would recommend shooting, go to measure, collect, shooting another point in a known point. So we haven't moved from this location. I'm going to shoot that point again and then compare the two. So point manager, create point manager, and then hit the little like do not enter sign, or the whatever icon you would describe that as. So no points are selected. I'm going to select this. You can see, I guess it's called data 5 because it didn't save that we were on control. You can see that it has a difference in elevation that shows the elevation numbers. I don't know why it's not, well, that is kind of different. 0.2 of a foot. Well, I guess technically not good at math. 0.3 of a foot or so. We're going to choose going to choose 9. We're going to hit the edit icon, and we're just going to look at the numbers. It could be helpful to take a photo. And then we're going to exit out of that. We're going to select 5. Oh, no, that didn't work. We had 2 points selected. The X would delete them. This icon would clear your selection. So clear, and data 5. Go to the attributes. Want to look at how close is that? Very close, but it has a different Z. So that's probably because we haven't set up the reference elevation. So even when you continue from previous setup location, you need to probably best practice is to do the reference elevation again. And it's always helpful to back check a previous point, because let's say you collect a bunch of data on day 1, then you come back, you collect a bunch of data on day 2. If you have this back check point saved where there's 2 points but at slightly different elevations, you will be able to correct all of the points from day 2 to match to data from day 1, the elevation from day 1. If you understand what I mean there, because you'll have you'll understand the difference between day 1 and day 2, and you could correct just by subtracting or adding, and you get the correct elevation. All right. So we're not going to continue on with this setup. We're going to do a new setup by setting up here. So we're going to hit new setup. That deleted the previously saved location. And what we're going to do is pick the total station up, move it directly over that point. Just gonna push this there, protect it. Make sure that the total station is secure. And you pick it up with your shoulder underneath it. Keep it steady. You don't want to tip it over from one side to the next. So this is a known point setup. On the tri-brac here has a little sight that looks through and straight down the center. And what it allows you to do is move and slide and rotate just a little bit to get this centered using the sight directly over a known point. So always make sure it's secure before you move it around. Try to get it by eye best you can. A helpful tip is to position the tip of your foot near the known point that you're trying to set up over, and then you're gonna use one eye and look through the sight here and try to move the whole tripod. Close, and you might need to rotate the whole tripod because the crosshairs in here are at 90 degrees from one another, and you might want to align them to be orthogonal or perpendicular to the points on your control point, to the lines on your control point. So if I use my toe there, and this can be a pretty tedious, tricky setup. You can loosen the screw just a little bit and rotate it slightly. You still want to keep the adjustment knobs as close over top of the legs as you can. So I would recommend rotating the whole thing. Okay. I wonder if I can. Problem with my phone is I have multiple cameras on it, and it likes to switch between camera to camera. So if I You can barely see that, but you might be able to understand. So if I move my foot underneath there, you can see the tip of my foot there on the and the crosshair is lined up with the corner of the striping, basically. So that's what you're doing. You're moving the whole tripod, rotating the tri-brack and the tripod to get those crosshairs lined up. You don't have to get the crosshair lined up and perpendicular, but it helps. You just need to get the point of the middle of the crosshair lined up with what you want there. So, and you can see how the plumb bob hook gets in the way, clears it up when you move it. But the thing isn't level right now, so that's one problem. Once you start leveling this out, it's going to become it's gonna misalign with that point, and you can see the notification you get when the instrument's out of level there. Instrument out of level in red. Can't continue. I'm gonna go to device, not setup, I don't think. Settings, because we want to see how out of level it is. It's not even within range there. So what do we want to do? What I'm going to do is I'm going to reset the tri-brack, so you can see these little lines there on the post. I'm just going to roughly get all the knobs at the same level, and then I'm going to adjust the legs just a little bit. Get that bubble closer. And we're out of level because the legs, they're all the same height, but I kind of moved one leg out more than the other, so they're that's why they're messed up here. So this side needs to go down. Get it close. And you don't, once we start positioning it again, you want to avoid like moving the legs. You kind of want to slide the whole thing over so it stays roughly level. You won't be able to see this, but I'm going to be with my foot underneath there. Actually, don't even move the tripod yet. Undo the screw here. You can see that just enough so that you can slide this around freely. I don't know if I will be able to show you this. I'm gonna have to leave the plumb bob hook in the way, but I can move the whole thing, and the hole on the top plate, you only have so much usable area to move around in, so it gives you a little bit of fine adjustment there. Okay, so looking through my phone is just so you can see it, because the GoPro is not zoomed in enough. But you can see crosshair. Let me try to get a better angle here. May or may not be able to see that. But the crosshair is lined up there, and we're closer to level. So level it as normal. Going to move this in a good location here. One thing to note when you're setting up the tripod is make sure that the legs aren't touching anything that might shake or move, like a fence or a guardrail. So I'm going to adjust one adjustment knob at a time until we're level, and then we're just going to make sure that we're still over that known point. So that's within a good level for me there. Setting is 6 seconds. I'm gonna look through this scope again, and I'm gonna adjust it a little bit. At this stage, you could shift around as long as you don't rotate the whole tribrac. You could shift around perpendicular directions without having too great of an effect on the level. So I'm gonna lock that down. I'm happy with that. Next, we're gonna go to setup. Use last instrument location. No. If we were still over there, you could, but we're not. Select and measure points to complete resection. Okay, so there's two different options here. There's resection and then known point. Resection is you could place this anywhere, and you'll have to review the written documentation to verify the angles, but position it anywhere, and as long as you're within a certain angle between 2 points, so you reference it to 2 points, and as long as you're like above 90 degrees but less than like I want to say 135 or something, 120 degrees from that point to that point, it will be a successful setup. And I would also recommend positioning the toll station to be to give you the furthest working distance as possible. Again, so let's say we're set up here, we could see a point over there, and we could see a point over there. It's within our correct angle. It's better to have one further away so that you have a longer working radius around the machine and still be within tolerance. So that's resection. You referenced the 2 points, known point, which is what we're doing right now. We're set up over a known point. We're set up over control 9. And then you measure out to another known point. And in this case, we're going to go to laser mode and measure out to the L in level 8. I forget what that is called. I'm going to go to create point manager. So let me clear all of my selections. Let me see this. Control number 4. Seal intersection. I'm in the wrong space. Control 6. Arrow. Getting closer. Go back here, clear all. Control 7. L. Okay, so Control 7 is the one I want to pick and choose. So we're going to go back to device, setup. Still unknown point. Number 9, you can see the toll station icon. It's positioned over number 9. Then we're going to choose Control 7. And we're going to move the laser to be as close to that intersection to that inside of the L as possible. So I'm going to use the rough sight to get me close. And I can see the laser on the wall, which helps because we're in the shade here. And I wonder if I can give you this view here. It's tricky to do. It's out of focus right now. Bring it into focus. Oh, I'm putting some pressure on the lens. Okay, I don't know if you could see that on camera, but looking through the scope on my phone, you could kind of get an idea of what I'm doing, using the adjustment knobs to get as close as I can. And I'm just going to look through the scope just to make sure I'm in focus.
and I'm all adjusted correctly.
I think that's close. Once you're close as close as you can, and it's selected, and the toll station is on the right point, shoot it. And this is what you're looking for. Measured distance is what you're measuring, so you set the toll station up here, and it's measuring out to that point. It should match as close as possible to the computed distance. Computed distance is in the data in the data collector between this point and this point. And those are perfect, exactly on the money right there. So that's what you want. Ideally, that's basically zero tolerance, zero tolerance. Ideally, you want to be within 1/8 of an inch of tolerance. Depending on the situation, maybe 3/16 is all you'll have to live with. But the closer to perfect, the better. And that's a good result. I'm gonna set it. So now the toll station is set up here, and we could continue collecting more points now that we have a slightly different vantage point. Let's say we couldn't see behind this column, now we can. And we could collect those points. We could also, let's say we need to lay out something like that target there. And since we're in laser mode, I wonder if I can find, what was that, Control 5? Okay, we're gonna go to, I don't think it was Control 5. Let me orient my plan here, get a better idea of where I'm at. If we're right here, it'll be Control 8. North is that way. So what I'm going to do is measure layout. We're going to try laying out some points now. And while we're in laser mode, the toll station is actually going to try to rotate. If I select 8, it rotates over there, aims the laser, aiming. Let's see how close it gets. And this is the layout mode where it is trying to tell you how close the measured distance is to the computed distance. So we're within 1/8 of an inch. And let's see how it looks on site, since this reference mark still exists here. And that's pretty much perfect. As perfect as we could get by just looking at a laser point on the wall. So that's really good and very handy. It's a cool feature that the whole toll station rotates to help you lay things out, and you could literally just look at the laser mark it on the wall or whatever. I don't really utilize that feature too often. I always like to verify what I'm looking at. In this case, it can be through the scope. And yeah, that looks like it's 1/8 of an inch off. So you'll want to adjust it a little. Well, I guess in this case, if we're laying out, you won't have a reference point on the wall. So it will be within whatever this says, if you mark it using the laser. What next? We can try laying out some of the bolts. I don't know what this means. Laser pointing to location. Oh, well, also, this is a new setup. Reference elevation. Before you start collecting or laying anything out, reference elevation is very important. So we're gonna exit out of laser mode, go back to prism mode, get in front of the toll station so it locks onto us, locked on, and we're gonna move over to our 0 point and set up our reference elevation. The most important thing to do before you start doing anything. We're gonna get that guy on the point, level this out, measure. That's this new setup is now at the right elevation. So let's try doing some layout, see how that works. We're gonna go to measure, we're gonna lay out these bolts. So layout. Let's say we want to lay out data 3. It gives you 9, and this works, you're always facing the toll station. So it's 1'6" to the left, 1'8" to the back, or straight back, directly back. So if I go, you're like working within a radius of the total station. So I could see that this is the bolt, so it makes it easy. If there's nothing on the field right here and we needed to lay this bolt out from scratch or nothing, then it would be a little bit trickier. We're within 1/8 of an inch. That's a good enough tolerance for me. Any more than 1/8 of an inch, once you go to mark that on the ground, you're gonna add another 1/8 of an inch. So it's helpful to get closer, but how close can you get? So 0 to 1/8 of an inch. You're gonna try to mark it with like a pencil or pen. Just mark an X on all sides, center of the point. And you could shoot the point. Let's say we do that. It stakes it, so it saves the position that you laid it out in reference to the position it should be, like basically measured distance versus computed distance. It allows you to get a report of comparing all the points that you lay out. So you get a deviation of this point was laid out a little bit 1/8 inch out of tolerance. That point was laid out way out of tolerance or whatever. And you can see horizontal tolerance is within 1/8 of an inch. Vertical tolerance is within 1/8 of an inch. That's pretty good. And we can also do laser mode. If you see this little option, this will aim approximate ceiling projection. I'm not familiar with that feature at all. Is this gonna try to measure the point directly above? I don't know what it's looking at. There might be something in the way. If I look at the oh no, it's looking at me right now. I don't know what that feature is. It's interesting. Aim to approximate ceiling projection and measure. Well, there's a lot more to learn on this machine. I don't know what that does when you're in laser mode. But we laid this point out. You might be able to see, or you might not be able to see, if I move here, that little green check mark, that means it was laid out within tolerance, within 1/8 inch of a tolerance. It's good. So you can continue this way, laying out. You can also go to the next point with the arrow, and it'll go to the next closest point. You can move, lay it out that way. So it's pretty much how you do it. Trying to think, what else could you possibly need to learn here? Resection is even easier than a known point setup. I don't really see the benefit in going through that. Resection, you could place the total station anywhere, and you could use the laser mode or the prism mode, and you just need to reference to 2 points. Whereas in known point, you've manually positioned it directly over top of this point, and you'll need to reference to 1. And it's very helpful to have the laser sometimes, so you don't have to walk all the way down there when you can just use the laser to collect the point or to reference. So let me think here. There's a lot of, let's say in Point Manager, you might want to change some information. Maybe you collected a point before you did your reference elevation by accident. You could go in here, make sure nothing is selected, go in here and change the elevation, Z. You can also change all the attributes in Point Manager. There's also a lot of like line work options. If we go to create line work, you can create a line, use the line tool from that point to that point, create, that point to that point, create, and so on. So let's say you have, in the past I've done control joints that will be covered up by tile, and you need to bring the control joints, the slab, up to the tile so the tile doesn't crack as the slabs flex and settle. Those control joints might be running like at certain weird angles. Use the line work so you know which point, where the control line is, where the end point and the beginning points are. Another thing you can use the line work for is collecting underground utilities. So when the GPR guys come out, ground penetrating radar, and they use spray paint, mark the ground, showing you where all the utilities are, and you collect points along that line, but you have like different utilities intersecting each other. Use the line tools to show you the path that the utilities are taking, as opposed to just seeing a bunch of scattered points on the ground, only differentiated by a name. So just to give you more visual. You can also do an arc. I'm not super familiar with how that works. I guess you could tell it a specific radius. I've never needed to use that function before. Let's see here. From model, technically you can bring in 3D models into this, but I don't think this data collector has enough processing power to like drive a model very well. You could create a grid. I've used this in the past for when you are verifying the building corners of a building layout. They give you the building corner and they give you 5 foot offset. I don't know. They give you 2 points, 5 foot offset from the building corner. And let's say you don't have it in the plans, you could create it. So maybe we need a 5 foot offset from this point, and we need some more points. There's your 5 foot offset, and then I'll end up deleting the extra ones that I don't need, but you have points orthogonal and on a grid. So I'm not going to create that. Deselect. Plan is just a viewer. It's not a whole lot for you to do. You could rotate your screen a little. I think create a line there. I'm not familiar with that tool. But you can measure things. Measure the distance between points if you need. 10 foot 10 between those. Pattern. I don't believe I've used this before. Yeah, I'm not familiar with that. Wall penetration. Define a line by selecting 2 points, one on each side of the wall. Press aim to locate the wall penetration point located directly between the 2 defined points. I've never used this before. That could be handy. I know that there's one feature that allows you to I think it's in tools, check the plumbness of a column or a wall. So what you can do with that, you don't need any setup involved at all, as long as you any specific setup, as long as you position the machine, level it out as you would right in front of a column. It allows you to select the bottom, the top, and it tells you whether it's leaning towards or away from you, and that's how it checks the plumbness. It doesn't do side to side plumbness, you always need to be facing it. Aim laser to wall reference point and press measure. I'm not familiar with that tool either. And this measure point 1 of 2. I guess this will allow you to measure points, the distance between 2 points without any setup involved. I've never used this either. Not really something that we bring out our total station for. Oh, it's in laser mode. Makes a little bit more sense. Let's see how that works. I've never used it before, not really something I think we need in our workflows, but certainly a tool that we have. And you can see reference elevation. It shows you the point because we're still laid out, or still set up here. I don't think we need to be set up to utilize this tool that I'm showing you right now. Alright, let me try measuring the distance between the edges of these oh, I missed. Oh, too far. It's a little bit laggy. There it is. Alright, I'm just gonna place this. I'm gonna shoot that guy. Measure 0.2 of 2. I'm gonna go on the same side, opposite side. And shoot that. Let's see, distance between them, 8 foot 8 from that point to that point. Vertical distance of a 1/2 inch between them. I don't know what SD means. Standard deviation, I think. I don't know how to explain that. But I think if there was a major difference in the vertical height, standard deviation would be higher because it'd be like the hypotenuse of the 2 points. Okay, interesting. So those are a couple tools in device tools that I think you could use without having to reference the machine at all. Turn 2, you could also have the machine turn directly to one of the points so you can see it moving. Just so, let's say you're at this point over here and you want it to look at you quickly, there it is. If we're near that point, just pick that point, it'll look towards us. And that's pretty much all I can think of for now. We went over the basics of everything, and we're just over 2 hours and 13 minutes. So what I'm going to do is just break down the machine and show you the end of that. Take the GoPro, put it back here. Bring this. I guess we can bring. We'll probably bring everything closer this way. All right. Just put this in there. Put this on here upside down because it like hinges over to cover it, like that. Okay, so as long as the app is all good, there's nothing to save here. You could press the button and turn it off. I just pop the battery out. It's fine. All the everything is saved in the data collector. There's nothing in here that needs to be saved. It's a good force of habit to make sure the adjustment knobs on the tri-bracket are all level. This fits in with the main aperture looking towards the straps. We'll go over some of the other accessories in there in a moment. Protective cover on there. Going to loosen everything here. And this strap got caught. Tighten all the knobs so during transport, knob doesn't fall off and get lost. It doesn't get wiggled loose. Put the buckle on here. All right. Pop the data collector off of here. And with the data collector, when you're done, I would go to exit. And I would also recommend, actually, if I haven't exited yet, we could export that data. Completely forgot about that part. Go to Jobs, Export. We don't need to reconnect for this. 3 file types. DWG for AutoCAD. SKP, I have no idea what that is. CSV is like an Excel spreadsheet of all the coordinates. And you can export a DWG state, I believe, meaning like the green check mark, the layout, the points that you laid out. Design being Honestly, I've done both of these. I have no idea what the difference is, but I'm just trying to explain what I think it is. Line work, if you made any lines and saved them, it'll export those lines as well. Here is where you change the file name. I would put a date there, today's date, the date that you captured the points, and then it goes into the folder and documents. So if you hit export there, it'll save a file of DWG. I also like to save a CSV. One more thing to note there. If this would respond, it's not working. Great. When it becomes unresponsive, I would hit the Windows button. That doesn't close anything, it just goes out to Windows. Okay, that's how you fix that. Before you export, almost forgot this. You need to zoom out so you see all the points. Hit the eyeball. That selects all the points within the viewport. See, 12.17 added. If you don't like that, you can also box select. And we got all the points. So it'll only export the points that you select in the DWG or CSV. And then you can export that out. I'll do that just for example. And go to the Windows button. Go to the files. If this will respond as well, yeah. This PC documents, it's like a quick access here, Trimble field link, but I'll go through in case this quick access gets lost. So this PC documents, Trimble field link. I think you need a double click because it's Windows. Since this does run Windows, you could connect a keyboard and mouse and make it a lot easier to navigate. Exports. You need a double click, and there's all your exports. Scenario 2 export, that's the one we just did. These are pretty small files, so every single export I've ever done is in here, 57 exports, pretty much. And the only way for you to export is through a USB drive. Let me see if I have a USB drive in my little kit here. This part's kind of important here. Not every USB drive will work. You need a skinny USB drive. That's basically the thickness of just the connector that will fit in this recessed plug. So you could plug that in right there. You can see that. And it opened up. I don't want that right now. Windows, file browser. If I gotta go all the way back to that thing, yeah. Exports. Tap and hold like you're right clicking in Windows. Copy. Go to your Samsung drive. For data collectors imports, from data collectors exports. But you won't have this flash drive. This is my flash drive, so you're gonna need to find your way around that. Good luck. Alright. Exported. And now you can bring that DWG into, and you can see it's 22 kilobytes, so it's not an empty file like you accidentally didn't select any of the points. Bring that into AutoCAD, and you'll see what a mess it is, because all those layers and file or point names that you created here, like control, data, ref elevation, base, and all the different layers they're on, none of those are going to be brought in to the DWG. Those layers only exist in Trimble Field Link, which is its own proprietary software. When you bring it into AutoCAD, I think you will have the layers there, but the points won't be applied to the layers. And the names on, on AutoCAD they'll just be floating in space like that. I think you can't turn the well, I think you can turn them off. It's tricky. It's a mess, but you got the point data there, and I guess that's all that really matters. But all your organization doesn't carry over to Autodesk or AutoCAD. But the organization I would highly recommend, because it helps you on projects where you're going to be coming back and returning to layout repeatedly. Organization is key to help you have a successful layout mission over like the course of several months. So I'm exhausted, spouting out information for like 2.5 hours. That's pretty much all I can tell you right now. We'll shut this down. Actually, I don't even think I exited this. I think I did exit it. Alright, we'll shut it down. It was not a big deal if I lost that data there. Pack it up. This is a good backpack just to keep all this stuff in during transport. For the most part, I keep all of the chargers on my desk, but if I go to a really big job, maybe it makes sense just to bring it with me. Bring these with me just in case, but for the most part, the batteries last me a full job by the time I need to return back to the office. Alright, just throw these in here. I'll deal with it later. And the GoPro, I'll edit the video, I'll keep that with me. Yes, the Prism, don't forget this. Make sure it doesn't drop. I'd recommend popping the battery out always, just in case you forget this on. I turned it off earlier. Oh, I probably forgot to mention is to also clean this when you're cleaning the total station lenses. So this needs to be as short as possible in order to fit within the bag there. So you want to make sure the bipod legs aren't longer, because they can be. Then open up the bag here. And you gotta stuff it in here with these other ones. Try to get it so all the points are facing downwards. And it is a pain in the butt to get this over top of that. Always is. I haven't figured it out after like 2.5 years of using this thing. It just does not work. Couldn't make the bag just a little bit longer. There it is. And it might not even fit with these with this thing here. Yeah. Of course. I don't even know how to get that to work. I think this needs to go down there. Yeah, there. As simple as that. Put it in there. Actually, I'm not going to be driving with this. I'm just going to head down the elevator. I'll just add, there's a couple of the, I think that Allen key, the big one, is what you would use to adjust the bubble level on the prism pole, like from the very beginning. The smaller Allen keys used to adjust the rough sight. Not that you would, but maybe it comes out of calibration and you need to align it up better. There's some other tools here. I'm sure I've used some of these before, but I don't remember where they go. This does have a key. It's tricky. I don't keep it locked. The only times I've kept it locked was when I was leaving it on, like in a site office, and I just want to make sure everything stays inside of here. Here's like a 1-inch extension for the top of the prism pole. I don't know why you need that. Here's like an extra antenna. You don't know why you need that. Here's a rain cover that pops into the lens on the front aperture of the total station. That could be handy. Active prism. There's like a cover in here to cover the total station. There's another small Allen hex that you'd use to adjust something else. Maybe this is for that. I don't remember. Or no, I don't know if I've ever used that. This screw goes for this PLS3 laser level. Shoots a laser straight out, plumb down and up top, if you could see that. And then it shoots a laser straight out like that. And they're all perpendicular to one another. There's also extra AA batteries, 3 AA batteries in the bottom of the case there for you. That's always helpful to have. It's pretty much everything inside of here. Some other random stuff, but that's fine. Alright, all set up. That's it. Good luck to you on your adventures.